MonB5G is an acronym for the H2020 5GPP ICT20 project titled Distributed Management of Network Slices in Beyond 5G. It provides a zero-touch management and orchestration platform to support large-scale network slicing and automatically manage the underlying communication networks without human intervention for 5G and beyond. The MonB5G system emphasizes security and energy efficiency, providing a distributed and scalable architecture for next-generation networks. A data-driven system relying on artificial intelligence techniques is deployed to distribute management and operational tasks throughout the network. Because of its design, it can adapt to changing conditions in real time and use artificial intelligence-based techniques to detect and mitigate attacks on the network to improve security and reduce reaction time thanks to a local decision-making process. In summary, the MonB5G system will enable network operators and service providers to offer a wider range of high-quality services to their users with a focus on adapting to new needs and delivering high-quality experiences.
MonB5G architecture consists of two layers: management and orchestration and infrastructure layers. MonB5G system integrates autonomous security orchestrator architecture to automate the processing of security incidents, enabling quicker and more effective reactions and minimizing impact of security threats. Countermeasures are deployed on demand via cloud-native function orchestrator, being able to reconfigure and change functions. The demo use case is the response to the aLTEr attack, which is the man-in-the-middle at the radio interface manipulating DNS queries to redirect user traffic to malicious servers. Software components such as device, 5G system, security tools, MonB5G components, malicious servers supporting the demonstration are native cloud and virtual network functions. UE Ransom is used to simulate the terminal and the base station. It also simulates the attack and redirects DNS requests to the malicious server. The 5G core network and the MonB5G security orchestrator are deployed on Kubernetes cluster and OpenStack project. Malicious DNS and HTTP servers are set up on virtual machines to process redirected user requests. Meanwhile, the monitoring system continuously monitors DNS messages via port mirroring on the N6 interface. Now, a user device tries to connect to the MonB5G website. Its DNS request is manipulated by the man-in-the-middle and redirected to the malicious DNS server. The result of the translation is that the user's device receives the wrong IP address to communicate with the attacker's web server. The port mirror on the N6 interface sends copied data via a VXLAN tunnel to the monitoring system, which transforms raw packets into meaningful logs. Several machine learning algorithms have been implemented to detect anomalies in DNS traffic. When an anomaly is detected, the detection function creates an incident event containing a description of the attack and sends it to the incident response function. Based on the inference rules, the decision engine takes the decision to use DNS over TLS to eradicate the attack. The decision engine sends the threat eradication plan to the actuator, containing two instructions. First is to deploy and configure the DNS over TLS server so that it relays messages to the legitimate DNS server, and second is to deploy and configure the DNS over TLS client on the device. The user experience is shown here in real time, beginning with the DNS query sent to the malicious server and ending with the resolution of the incident. The device uses DNS of TLS to resolve its domain names. The attacker can no longer manipulate user data. the device reaches the website safely. At the N6 interface, the previous clear text DNS packets are now replaced by the TLS packets. From the device's point of view, the browser first receives untrusted data from the malicious web server. Then, after reloading the web page, it receives trusted data from the legitimate server, as the attack has been eradicated. Incident detection time is the time elapsed between the moment the device transmits the manipulated packet and the indication of the incident. Incident resolution time is measured from incident indication to full deployment of the eradication solution. Testing shows the security orchestrator's performance in detecting and eliminating threats is in the order of seconds. Deploying automation with AI and security tools reduces the time taken to identify and eradicate threats. Orchestrating security functions strengthen the defense dynamics.